Hello students, how are you all? So let's begin. So we continue with the third chapter, Emerging Trends. Last class we saw artificial intelligence and robotics. This class we will start with machine learning. Machine learning is a subsystem of artificial intelligence. So here the computers have the ability to learn from the data, the knowledge base, using statistical techniques and without being explicitly programmed by a human being. So where a human is not giving explicit instructions, but the computer is going to use the data that they have in the knowledge base, and they are going to use statistic technologies to carry off the work. So if there's an ordinary system, then imagine the system with AI, and then with machine learning, it's only the machine with understanding the data, applying the statistical techniques, and coming to a result. So this machine learning helps us to learn. They can even make predictions, and it improves over time. Okay. It comprises of algorithms that use data to learn on their own and make predictions. These algorithms are called models. They are first trained and tested using a training data and testing data respectively. These algorithms are called models, and they are first trained and tested using a training data and testing data respectively. After successive training, once these models are able to give results to an acceptable level of accuracy, then these machines are used to make predictions about new and unknown data. So these predictions can be that can range from whether a piece of fruit in a photo is a banana, or is that picture of an apple. Spotting people crossing the road in front of a self-driving car, whether the use of word book in a sentence relates to paperback or a hotel reservation, whether an email is a spam, recognizing speech accurately enough to generate captions for a YouTube video. All these are examples of machine learning. Some well-known machine learning are spam detection for email accounts, self-driving cars, credit cards, that is fraud detection for credit card usage. Amazon and Netflix, there are recommendations which other products or movies a customer may like. All these are based on the customer choices. So this cannot be explicitly taught to a machine that if a person likes this cereal, he will definitely like this cereal. No. How does this machine learning work? The machine learns the kind of movies or the kind of series or the kind of videos you're watching. Then that machine will analyze and determine a statistical report, and he will learn from that report and then make you suggestions of the kind of other movies in the same genre that you have not watched, and then they will tell you will like this genre. So these are the movies that are new that you want to watch. Even Google shows the most useful search results. In Facebook, personalization of a user's feed or determining which user a specific ad should be shown. This you all must have noticed if you all are shopping on your computers or your phone. When you all are in Facebook, you'll suddenly get an ad with the same shoes or the same bag or the same clothes. This is because of the machine learning. Amazon's Alexa, speech recognition for virtual personal assistant, and Instagram, that is face recognition and applying filters to video. These are all examples of machine learning. These are some well-known and some less known machine learning examples. The machine learning is a subsystem of artificial intelligence, and over here computers have the ability to learn from the data using statistic techniques without being explicitly programmed by a human being. So they have algorithms, and these algorithms are constantly, the machine is constantly trained and tested repeatedly on a very repetitive basis. And when after a few repetitions, they test and they feel that the result is acceptable, the accuracy level is acceptable, then they start using the machine to make predictions about unknown data. We watch a video of this.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. The technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter.
So this was machine learning. I will also share one more thing with you. Give me a minute. Have you ever played this game, Quick Draw? Can a neural network learn to recognize doodling? Help teach it by adding your drawing, that is, you're adding data to the world's largest doodling data set. Machine learning research. Let's draw. So it's saying draw a television under 20 seconds. So I'm going to start drawing a television, how I
see elbow,
would look at it.
or foot, or picture frame. I see oven. I see dresser. I see microwave. I see calendar. Sorry, I
did
couldn't
not
guess
get it. I'm a bad drawing person. Okay, we'll try again. Let's try the laptop. I should get this.
I see triangle. Oh, I know. It's laptop.
See, that was quick. Okay, this one is difficult. Let's try.
I see circle, or moon, or boomerang, or bracelet. I see frying pan. Oh, I know, it's hockey puck.
Wow. An arm.
I see line. I see hockey stick, or crayon. Oh, I know, it's arm.
See, so this is machine learning, and it's learning from my drawing. It's able to recognize it. A hot tub.
I see foot, or shoe, or bathtub, or hot dog. Oh, I know, it's hot tub. I see circle, or moon, or blueberry. Oh, I know, it's basketball.
Okay. This one I went wrong in television. I went really, really bad. If I touch it, I can see which were the other options. So this is what other people have drawn, and this has helped him understand that this was not a television. His closed guesses were these. Let's see the laptop. And laptop, he said very quickly. So this is how others have drawn laptop. And he recognized it with the way I drew it. This is machine learning. Last class we did artificial intelligence, that is using Alexa or Google, in which these people are given facts. They've been told that if this is the question asked, this is the answer. They're pre-fed. But over here, the machine learns from the statistics on its own. Okay, it collects data, it performs statistics techniques on it, and it learns. All right. Okay, let's move further. Natural language processing. What do you understand by the term natural language? The predictive typing feature of search engine that helps us by suggesting the next word in the sentence is natural language processing. It's an example of NLP. NLP deals with the interaction between human and computers using human spoken languages like Hindi, English, etc. It is an interdisciplinary field of computer science and linguistics. Interdisciplinary is a mixture of two fields, computer science and linguistics. NLP is the ability of a computer to understand human language. An NLP system can perform text to speech and speech to text conversion. This NLP deals with interaction between humans and computers. It is possible to search the web or operate or control our devices with voice nowadays. All this is possible because of NLP. So here I have shown you an example where she's telling Google that play attention, and attention is playing on Spotify. How did it happen? You know, when you tell that, you get a reply saying, sure, playing Attention by Charlie Puth from Spotify. Then it goes and it searches for the song, and then it plays. This is natural language processing, where you can speak to the devices. You can apply this technique. Natural language processing is applied in when we are typing keywords and we get the next suggestion, and also when we are using devices with our voice. Machine translation is a rapidly emerging field where machines are already able to translate text from one language to another with fair amount of correctness. Another application area for this service is a customer service, where a computer can interact with customers to serve their queries or complaints. That is chatbots. Chatbots also use NLP. Using natural language processing, automated messaging programs simulate human conversation and customer service. Expedia has developed a chat box for customers to check their trip status, find hotels, and book hotels. I want you all to write down in the comment section of this video if you think NLP, that is natural language processing, can help differently abled people in any way. Do you think NLP will have any use over there? Let's see a video for NLP now.
Natural language processing allows computers to understand human language. Let's take a closer look at it. Natural language processing, or NLP, has plenty of applications. For example, text summarization, translation, keyword generation, sentiment analysis, or chatbots. So how it works? We start with lexical analysis, also known as tokenization, which divides text into paragraphs, sentences, and words. Then we proceed with syntactic analysis, or parsing. Parsing goes through sentence word by word to create structural description of a sentence, usually in a form of tree. It applies rules of context-free grammar to identify whether the word is noun or verb, and so on. This helps to understand the relationships between words. Once we know the structure of a sentence, we need to find out its meaning. This is the most complex phase because natural language can be quite ambiguous. A simple sentence can be interpreted in many different ways. Semantic analysis gives us context-independent interpretation, or in other words, a meaning without knowledge of the other sentences. The result is called logical form. At this point, there is still maybe some level of ambiguity, so we call to help pragmatic analysis. Pragmatic analysis can derive better interpretation of the sentence by looking at the previous and succeeding sentences. It also applies real-world knowledge. For example, that banana is a fruit, birds can fly, and so on. Finally, it's worth noting that sometimes syntactic analysis, semantics, and pragmatics aren't completed in a sequential manner, but rather simultaneously. Even though NLP is a young field, we've made quite progress over the last few years. With advances in machine and deep learning, it will be interesting to watch how the way humans and computers communicate with each other evolves. And as always, thanks for watching.
Okay, so this was NLP, one way of it. So last class, I had not shown you all a video of robotics. This class, we'll see a little video of robotics also.
thing I love most about robotics is the challenge of figuring out what makes things function intelligently in the world. Sensing and control, mechanical design. How do we control the robot fingers so that they're able to achieve some of the dexterity that people can achieve? And robotics at Harvard has had a wonderfully experimental phase. We build things and test them and make them work in the real world. It's not just a theoretical exercise.
Soft robotics is an emerging field within robotics. In this lab, we essentially say that there's a huge opportunity to apply small, moderate levels of assistance to people. You don't need to give them superhuman strength, but that in itself can have a pretty big impact in terms of their mobility and quality of life. This could be people who suffered a stroke, it could be elderly people, children with cerebral palsy. So we're trying to think about how do we develop new types of wearable technologies that allow them to move around more naturally like a healthy person.
What we're trying to do is make robots smaller, softer, safer to interact with, more effective because of they're either more agile or can maneuver in places that big bulky robots wouldn't be able to do. Example applications include search and rescue, hazardous environment exploration, biomedical applications, things inside the body, things where you wouldn't want to put a human or an animal.
One of the applications that I'm really interested in is whether you can get robots to construct things. Ultimately, what would be really cool is if you had a disaster area or there was a flood, and instead of sending a bunch of people into a dangerous area, you sent a bunch of robots and they picked up the sandbags and made walls. You can't make a robot unless you understand mechanical engineering, electrical engineering, computer science, and then it actually helps to understand biology because biology is the best example of autonomous systems. I do try to work closely with people from many disciplines. In fact, that's what I like a lot about being at Harvard, that's so easy to do.
It's a great place to find academic collaborators and certainly medical collaborators as well. Key benefit of SEAS is that although we're growing, we're still somewhat small. That makes us very nimble, very agile. We can put together interdisciplinary teams very quickly. We've really reached an important cusp in robotics. There'll be any number of important applications in industry, households, hospitals, factory floors, all sorts of new places.
Almost every application will have multiple robots.
Assisting with tasks that are difficult, dangerous, extraterrestrial, whatever they are. A number of robotic startups taking the ideas from research, turning them into practical applications, skyrocketing, and we're very excited to be part of that.
If you think about the last 20 years, the internet has really transformed our lives and the way society works. But going forward, I think robotics is going to be playing that big a role.
That was robotic. That brings us to the end of today's class. Stay home, stay safe. Write that answer down in the comment section. Okay, take care and keep learning. Thank you.